Who said smaller angle approximations are easy? 9-mark question. It probably is easy, to be fair. It's just solving quadratics, quartics, all of that good stuff. So what does it say here? It says given that theta is small, find approximate solutions to this for 7 marks, then comment on the reliability. So nice and simple. We just need to focus on what we know. We know for theta being small, sine theta is approximately theta. Yeah, y equals x. Yeah, and that's the same with tan. It's about theta. Cosine, a little bit different. Now the cosine graph has an arc at the beginning, so it's a negative x squared, but it's a negative x squared that has moved up because it crosses the y-axis at 1, so 1 minus x squared. But it's not it's very close to 1 minus x squared, but it's a bit more flat, which is why we divide by 2. Okay, at A levels you don't need to prove these. Further maths, we can prove them really easy using Maclaurin series. So let's go one by one. What about cos of 4 theta? And there we have to be careful because we are squaring it, but we're squaring that whole function of 4 theta. Now here we have to be careful because theta is just being replaced. What do you think the most common mistake is? Is students just multiplying through by 4? They think, oh, cos of 4 theta is 4 minus 2 theta squared. Guys, the 4 is not here, is it? We're not multiplying through by 4. It's within the angle. You are replacing, this is like functions. You're replacing the theta with 4 theta. So it becomes 1 minus 4 theta squared all over 2. 4 squared is 16. 16 divided by 2 is 8 theta squared. Don't forget your theta squared. Okay? So here I'm going to have 4. Then we are squaring this. So we're squaring this. 1 minus 8 theta squared squared. Now this, again, another common mistake students would make here is they think it says sine squared 2 theta. It says sine of the square of the angle. So that's like saying sine of 4 theta squared. That's what that's saying. You're squaring the angle, which is approximately 4 theta squared. Okay? Sine of theta is approximately theta. Sine of 4 theta squared is approximately 4 theta squared. So we get minus 4 theta squared, all divided by tan squared theta. Tan of theta is approximately theta, so we just get theta squared is 12. Now solving this is giving me hidden quadratic vibes. All of these are theta squared. I'm going to let it equal u. All right? It's just going to make life easier to write down. It's just like having, say all of these said tan squared, tan squared, tan squared. If you just let it equal u for a bit, it's just easier to write down. Okay? You don't have to do it if you don't want to. So I'm going to let u equal theta squared. I think some of you guys call it pseudo quadratics. But anyway, 1 minus 8 u squared minus 4u all over u is 12. Expanding this, 1 squared is 1. Multiply these together is minus 8u. Duplicate it, minus 16u. Plus, when you square that, you get 64u squared. Minus 4u is 12u. Is your next thought to expand the brackets? I wouldn't do that. I would divide everything by 4. So 3. So we have 1 minus 16u minus u is minus 17u plus 64u squared is 3u. So we get 64u squared. When you minus that, you get minus 20u plus 1 is 0. Okay, can't be bothered to think about this one, so I'm just going to use the calculator. 64 minus 21, a quarter and 1 over 16. In the exam, you have to pretend like you did factorize. 4u minus 1, 16u minus 1. But don't forget, u was actually theta squared. So when we square root, you get plus or minus a half and theta is plus or minus 1 over 4. Okay? Then part B says, comment on the reliability of your solutions. Now with this one, I would say that they're both reliable as small. Essentially, you want to keep theta to be between 1 and minus 1, okay? And it's kind of like the same reasoning in general, but it's the same reasoning basically when it comes to geometric sequences and the binomial 1 plus x to the power of n, keeping modulus x be less than 1. It's kind of the same reasoning there because of these expansions here. So you want this modulus to be less than 1, okay? So both reliable as modulus theta is less than 1. However, I would just say that the quarter is more reliable than a half because it's closer to 0. So the closer you are to 0, the more reliable the solution. However, theta is plus or minus 1/4 is closer to 0, therefore more reliable. So if possible, use those values instead of plus or minus a half. But they're both good solutions. So yeah, that's it, guys. Nice one, Mike. If you learned something today, I would appreciate if you hit the like button. Subscribe for more maths content. If you want to join the Lung Gang Reddit page, which is where one of the students sent this to me, the link is in the description where you can submit your own. And if you're interested in my A-level maths courses, link is also in the description. See you guys in the next video. Nice.